Hi folks, we're going to take a look at page 245, number 19a. So they want us to prove this identity. So I'm clearly going to start with the right-hand side, much more complex, a lot more that we can do with it. Okay, and let's see what happens here. So I've got 2, and I'll use square brackets just to separate it out. So if I take a look at this first expression in the bracket, pretty clear. I'm just going to change sine 2x using the double angle formula. So cos x times 2 sine x cos x. Okay, and then here minus sine x. And this is where I have to make a decision because I've got 3 versions of the cos double angle formula. The question is which one's going to work? So I'm going to take a look at what I have on this side here. And I notice that I'm going to end up with a sine times cos squared. Okay, so if I were to replace this, say, by, cos squared minus sine squared, I'd end up with a sine cubed. No sine cubes here. If I replace this by 1 minus 2 sine squared x, again, I end up with a sine cubed. Whereas if I replace it by 2 cos squared x minus 1, I'm going to end up with a sine cos x squared, like I have here. So I'd much rather recreate the same expression that I already have, even though it's complex, than bring in some new one that does not appear in my previous expressions. All right, and here the denominator, clearly not much else to do but to turn this into 2 sine x cos x. Okay, and right away something nice happens because this 2 is a factor of the numerator because it's multiplying this whole big bracket. So I can reduce these 2's there. So let's take a look and let's simplify this here. So here, as we said, we end up with 2 sine x cos squared x, okay, minus, okay, well, again, look what we end up with, 2 sine x cos squared x. And so that's very nice because these 2 are just going to cancel out. And then here I've got negative sine x times negative 1, so plus sine x. Okay, all over sine x cos x. All right, so here some very nice things happen because these 2 things just subtract to 0. So the only thing I'm left with is sine x over sine x cos x. And again, the sine x's cancel out, and so all I'm left with from this big expression is 1 over cos x, and of course 1 over cos x is the same as secant x, which is my left-hand side. All right, so just to do a quick recap here, most of what I did, I just followed, the only options that I had. So here, I needed to change both of these 2 into 2 sine x cos x. It was this one here where I had to do a little bit of investigation. So because I was already going to end up with that sine cos squared x, it made sense to replace cos 2x by this version. And then from there, the algebra just took me to where I needed to go. All right, that's it for this.